So in class last week, we were talking about excitations. So spectroscopy, and when we were doing UV-vis spectroscopy, we're exciting one electron from one orbital to another, and then that absorbs energy. So, but when we're talking about transition metal ions, last time we said that if we're comparing titanium 3+, octahedral, for example, we have one electron in the ground state. This is D1. And then so you only get one band because when you excite electron from this triply degenerate T2G orbitals to the EG, you just have to excite across this energy gap, which is, remember, delta O. On the other hand, when we compare this to the vanadium 3+ octahedral, which is D2, then we want to think about, in our excited state, we have, so our ground state has 2 electrons. Our excited state, we've excited one of these electrons to this EG orbital. And then, but what we saw in the actual spectrum was that there were 2 peaks in this UV-vis spectrum. And the reason because of this is due to electron-electron repulsion. Namely that this configuration, because these are actually in real life orbitals, so if we have xy, yz, xz in our T2G, and then we have x squared minus y squared and dz squared, this occupation of these orbitals might have a different energy than if we had, for example, this excited state. Because we have 2 electrons, and then they're located in space, they have electron-electron repulsion. So having this occupation of orbitals might be different energy than this one. And then so this brings us to some terms that we'll want to know for this part of the course. So configuration is actually what we're used to. So electron configuration. This has to do with your kind of assignment of electrons and number, and given a given number of electrons. So for example, this one, okay, so if we think about having a number of electrons in d orbitals, so for like a free atom, we have 5 d orbitals. We could have, let's say, d2, for example, d2, right? So and then you could arrange these atoms in whatever, or these electrons in any of these orbitals. But we have 2 electrons, and they have to be somewhere in these 5 d orbitals. That's a d2 configuration. When we get to an actual molecule, so vanadium 3+ is d2. But then we could actually think about orbital configurations. So this, for example, would be a configuration of both of these. It would actually be T2G1, EG1, because we have 1 electron in the T2G set, 1 electron in the EG set. And then for this example, this would be the configuration of T2G1, right, EG0. So the configuration is this. And remember, both of these kind of arrangements of electrons have the same configuration. So the configuration doesn't tell us the actual energies of what we might see for having these electrons. It just tells us which orbitals they're in. So for a given configuration, we might have multiple terms. So a term is also equal to 1 energy level or set of energy levels of a system. And this is also called a state. And then these terms are described by term symbols. By term symbols, okay. So what this means is that, so you might have heard me refer to ground state, right? So this is what I said was the ground state of this T2G1 electron configuration. So this is the lowest energy state or term. And then for this to have 1 band in the UV-vis spectrum, we must have 1 excited state, which must have its own term symbol. So for this D1 octahedral complex, we should have 1 term for the ground state and 1 term for the excited state. And keep in mind, again, the excited state for this is going to be EG1. So this will be a different configuration. But both of them are still D1. They just change the orbitals. For this, the ground state is of vanadium 3 plus, we have D2. The ground state has to be 2 electrons in the T2G, so the configuration is T2G2, and then that has one term for the ground state. But then this excited state, where we have this configuration T2G1, EG1, this excited state will have two terms. So there's two excited states with this electron configuration. So we'll do some practice examples of this in class. Oh, and then keep in mind, we might have additional excited states with different configurations. We could imagine exciting both of these electrons of this D2 configuration up to the EG orbital. And then from that, we might have multiple excited states and terms for that configuration also. So keep in mind the difference between these two. Again, one configuration could have multiple terms or states associated with that.